You think teleportation is just a technology problem. You imagine engineers, machines, energy, maybe one day advanced enough computers.
You think the only thing missing is progress. This is wrong. You picture your body as a complicated object.
Atoms arranged in the right pattern, information that can be scanned, copied, sent. But you are not a statue made of particles. You are not a frozen arrangement waiting to be duplicated. At the deepest level, the universe does not even allow the kind of copying you are imagining. Not because we lack power, not because we lack intelligence, because the rules themselves forbid it. You assume that if we could measure everything about you perfectly, we could rebuild you somewhere else. But everything is not measurable in the way you think, and perfectly is not a word quantum physics tolerates. The problem isn't engineering. The problem is that reality refuses to be fully known, refuses to be fully copied, refuses to let you exist twice. And once you see why teleportation stops being futuristic, it starts being impossible. You think of yourself as a thing. A complicated thing, yes, but still a thing, a structure made of atoms, molecules arranged just right, a biological machine with parts that can, in principle, be taken apart and rebuilt. If I freeze you in time, you imagine I could take a snapshot, capture every particle, record every position, log every velocity, and if I had that snapshot, I could build you again somewhere else. This feels reasonable. After all, we rebuild engines, we replicate computer chips, we even clone biological tissue. So, why not a person? Because you are not a frozen arrangement of matter. You are a dynamic quantum system. Every atom in your body is not a tiny marble sitting somewhere precise. It is a cloud of probabilities, a spread out possibility. Even now, as you sit still, trillions of quantum states inside you are not sharply defined. They are described by wave functions, mathematical objects that encode probabilities, not certainties. You do not have exact positions in the way your intuition demands. You have distributions, and these distributions are not just messy because we lack good tools. They are fundamentally indeterminate. Your brain, your neurons, the ions moving across synapses, all of it rests on quantum behavior at the smallest scales. You imagine teleportation as copying a sculpture, but a sculpture is static. You are not. You are closer to a symphony being performed than a statue being displayed. A symphony is not just the notes written on paper. It is timing, phase, interference, subtle correlations. Miss the relationships, and you don't get the music back. Now consider this carefully. To teleport you, we wouldn't just need the ingredients. We would need the exact quantum state of roughly 10 particles. Not just what they are made of, but how they are entangled, how their probabilities overlap, how their uncertainties relate to one another. You don't simply occupy space. You exist as a vast web of quantum correlations. And here is the discomfort. That web is not something you can treat like a list of coordinates. It is not a blueprint in the classical sense. It is a fragile, evolving pattern described by amplitudes, numbers that encode not just likelihood, but phase relationships that have no classical analog. If you change those phases slightly, you don't get almost you. You get something physically different. So when you imagine teleportation, you imagine scanning matter like scanning a 3D object, but you are not an object in that sense. You are an ongoing quantum process, and processes are not captured by snapshots. They are described by states that cannot be treated as classical data. Already, the problem is deeper than engineering. It's not about precision tools. It's about the fact that you are not the kind of thing that can be perfectly specified the way your intuition expects.
And we haven't even reached the real limitation yet. You assume the obstacle is resolution.
If only our scanners were powerful enough, if only our detectors were sensitive enough, if only we could zoom in far enough, then we could measure everything. That assumption is inherited from classical physics. In the classical world, uncertainty is ignorance. If you don't know something, it's because you haven't looked carefully enough. But quantum mechanics rewrites that rule.
At the smallest scales, uncertainty is not a flaw in your instruments. It is a property of reality itself.
Consider a single particle. You want to know exactly where it is and exactly how fast it is moving. This sounds harmless, but the more precisely you define its position, the less precisely its momentum can exist.
Not be measured, exist. This is not a technological trade-off, it is structural. The universe does not assign simultaneous, infinitely precise values to both.
There is no hidden list of exact numbers waiting to be discovered. There is only a wave function, a spread of possibilities. You might think, fine, we'll measure position first, then momentum. But measurement in quantum mechanics is not passive.
To measure is to interact. To interact is to disturb. When you measure position with extreme precision, you force the system into a new state, one with large momentum uncertainty. You don't reveal the old reality, you create a new one. Now scale that up. Imagine attempting to measure the exact quantum state of every particle in your body. Every electron, every proton, every entangled pair. Each precise measurement would alter the system.
The act of extracting perfect information would destroy the very state you are trying to record. This is not sabotage by poor engineering.
It is written into the mathematical structure of quantum theory. The information you would need for teleportation is not fully accessible, even in principle.
And here the discomfort deepens. Teleportation requires a complete description of your quantum state. But quantum mechanics denies the possibility of complete knowledge. There is no master file containing all properties simultaneously well defined. There is only a probabilistic structure that collapses differently depending on how you probe it.
So when you imagine scanning yourself perfectly, you are imagining something that the theory itself forbids.
Not practically difficult, logically forbidden. You cannot extract all the information without changing it.
You cannot observe without rewriting, and if the act of measurement rewrites the state, then the you that gets reconstructed would not be the you that was scanned.
The problem is no longer about storage capacity or transmission speed. It is about the impossibility of obtaining the full quantum description in the first place. And we still haven't touched the rule that makes copying itself impossible. You believe information can always be copied.
You copy files, you duplicate photos, you back up entire hard drives without changing the original.
So why not copy a quantum state? Because quantum information is not classical information. In classical physics, a system has definite properties whether you look at them or not. You can read those properties and write them somewhere else. But in quantum mechanics, the state of a system is described by a wave function. And if that wave function is unknown, which it always is, in practice, there is no physical operation that can create an identical copy of it. This is not a limitation of technology. It is a theorem, the no-cloning theorem. It states that there is no universal machine that can take an arbitrary unknown quantum state and produce two identical copies.
Not difficult, impossible To understand why, imagine trying to build a copying machine. You feed in a quantum state.
The machine reads it out, puts two identical versions, but quantum states can exist in superpositions.
They can be combinations of possibilities with specific phases. If your copying machine works perfectly for one state and perfectly for another, linearity, the core mathematical structure of quantum mechanics, guarantees it will fail for their superposition.
The math refuses to cooperate. There is no workaround, no clever engineering trick. The universe does not allow arbitrary quantum states to be duplicated without destroying the original information. Now think about what teleportation demands. To teleport a human, you would need to copy the complete quantum state of roughly 10 particles. Not approximate it, not simulate it. Copy it exactly. But the no-cloning theorem says you cannot copy even one unknown quantum state perfectly. Not one electron, not one atom. Even if you could measure everything, which you cannot, you still could not duplicate the full quantum description without violating the structure of quantum mechanics itself. The restriction is not about size, it is about principle. Quantum information behaves differently from classical information because it is embedded in a linear, unitary framework where copying arbitrary states breaks consistency. You might think, then destroy the original. Fine, don't copy, transfer. But even transfer requires extracting the state's full information content without leaving a duplicate behind. And the act of extracting that information runs straight into the same mathematical wall. The universe protects the uniqueness of quantum states. It does not permit duplication of the unknown. Teleportation, as you imagine it, scanning and rebuilding, depends entirely on the assumption that information can be copied freely. That assumption is wrong, not technologically premature, wrong at the level of physical law, and once copying fails, teleportation begins to collapse with it. Let's assume something generous.
Let's assume you somehow bypass measurement limits. Let's assume you respect the no-cloning theorem by agreeing to destroy the original. Fine, you won't copy yourself. You'll disassemble yourself completely. Extract every bit of quantum information.
Transmit it. Rebuild elsewhere. This sounds more consistent. But now the problem changes. To obtain the full quantum state of your body, you would need to isolate and measure every particle with extreme precision.
Not biologically precise, quantum precise. That means interacting with each electron, each nucleus, each degree of freedom. Your body contains roughly 10 atoms. Each atom contains multiple quantum states, spin orientations,
energy levels, entanglement relationships. To resolve them, you would need interactions energetic enough to localize them beyond their natural quantum spread.
And localization requires energy. The tighter you try to confine a particle's position, the larger its momentum uncertainty becomes.
Large momentum uncertainty means large energy fluctuations. In other words, extreme measurement requires extreme disturbance. To fully scan yourself at quantum resolution would not resemble a medical procedure. It would resemble annihilation. You would need to break chemical bonds, strip electrons, collapse delicate entanglements. Your neural patterns, the electrical and chemical processes sustaining consciousness, would not survive this extraction. Teleportation is often imagined as a beam that dissolves you gently, but quantum precision does not allow gentleness. To resolve every quantum degree of freedom, You would have to dismantle the system down to its most fundamental components.
You cannot preserve biological integrity while extracting total quantum information. The process of perfect disassembly is indistinguishable from destruction.
Now, consider something subtler. Even if you accept destruction, even if you accept that teleportation requires killing the original, the energy required to isolate and encode that much quantum information would be astronomical. You are not just atoms, you are thermal motion, vibrational modes, quantum fluctuations in a warm, noisy environment.
Your body is not a clean laboratory system near absolute zero. It is a hot, decohering, chaotic quantum object. To freeze that chaos into a precisely known quantum state would require isolating it from the environment in ways that contradict thermodynamics at scale.
Teleportation assumes you can pause the storm. Quantum physics says the storm is part of what you are.
And once you accept that the scanning phase requires total disintegration, teleportation stops being transportation.
It becomes destruction followed by reconstruction. The comforting image of stepping into a machine fades.
What remains is a machine that tears you down to quantum fragments, because that is the only level at which the information could even, in theory, be handled. And we still haven't asked the deeper question. If something is rebuilt, is it you? Let's say the impossible happens.
You are fully disassembled. Every quantum detail somehow captured without contradiction. The information transmitted. A new body reconstructed elsewhere. It looks identical. It remembers your childhood, your fears, this very moment.
It insists it is you, but are you there? You assume identity is pattern continuity. If the arrangement is the same, the person is the same.
That feels natural. After all, your atoms already change over time. Cells die. Molecules are replaced.
Yet you still consider yourself the same person. So why not across space?